Don't you hate it when you see a really easy looking problem on the screen, but you completely forgot your formula? Take a look at this problem, for example. It's a rate problem that involves distance, time, and rate. Now, is the correct formula to solve this d equals to rt, r equals to dt, or t equals to dr? Which one is it? The second one is never the correct formula in any situation. Most of the time, a vast majority of the time, the first one is the correct formula. In rare situations though, the third formula can also be correct. Now, many of you may be shocked to hear that, but please don't judge me until you watch to the end of the video, okay? Now, you'll be very happy to hear that sometimes the correct formula can be derived from the problem itself. But let's go over some real life examples before we do this problem. Let's say you want the formula for density. You know that density depends on mass and maybe volume, but you're not sure what the formula is. But you do remember that the unit for density was written as kilogram per meter cube or gram per centimeter cube. So right here you can see that density is given by kilogram is the unit of mass and meter cubed is the unit of volume. So density is equal to mass over volume. Similarly, pressure. You don't know the formula for pressure, but you've heard of PSI. Now, you'll not be tested on physics, of course, so I'll just tell you that the P part of PSI is not pound, but close. It's pound force, and SI is square inch. So as you can see, pressure is given by the pound force is the unit of force, and square inch is obviously area. Formula for pressure is force divided by area. Now, problems involving density or pressure are very unlikely to be on GMAT and GRE exams, but trust me, this will be a very good lesson to apply in the previous problem and other GMAT and GRE problems in which you may have forgotten the formulas. Just watch. As we said before, we already know that there is time, distance, and rate involved in this problem. We just have to figure out a way to connect them into a formula. Notice that the problem says the rate is in kilometers per hour. And I'm sure you know that in mathematics, the word per means division. For example, percent is division by 100. So we have the rate in terms of kilometers per hour. Kilometers is the unit of distance and hour is obviously the unit of time. And you can rearrange the variables and get the more commonly used formula d equals to rt. You must have seen this somewhere. Now that we have the correct formula for distance, rate, and time, let's use this formula to solve the problem. Distance d is k kilometers. The rate is 30 kilometers per hour, 30 km over 1 hr, times time is the missing variable, how many minutes. Whenever there is what or how many, it's the missing variable that you're trying to solve for. So we'll just keep the variable t here. Now let's solve for t in terms of the rest. That gives you t equals to k kilometer over 30 kilometer times 1 hour. That is equal to k over 30 hours. Notice the unit, but they want the time in terms of minutes. If you don't bother to convert the units, you will get the wrong answer. D is the trap answer here. In this video, we're not particularly focusing on units conversion, so I'll make it quick. But if you're not so confident in converting from one unit to another, I'll make a longer video with a slightly harder example in which I'll show you in detail not just one but two ways to convert between similar units. So check the description for the link to that video. Okay, to convert from hours to minutes, you can simply multiply by 60 because 1 hour is equal to 60 minutes. That gives you 2k minutes. That is the right answer. Now, some of you are probably thinking this problem could be solved without knowing this formula at all by just setting a proportion, and you are 100% right. And those of you who are curious, let me show you. Now, in the actual exam, you'll probably be given that Barry's rate was uniform. Okay. So in my problem, I wrote this problem so it was implied that he was consistently running at 30 kilometers per hour. By the way, that's very, very fast. Even the fastest man on earth, Usain Bolt, can run a little faster than this when he runs 100 meters. I very much doubt that he can run a kilometer or even maybe 500 meters at this speed. So rest assured that Barry is a fictional character here. Okay, we're talking about a proportion, right? So proportion, since the rate is uniform, the ratio of distance and time for Barry will be consistent because distance and time is nothing but rate, okay? So since distance to time ratio will be constant, we can say that distance to time ratio for a certain instance will be the same as distance to time ratio for another instance. So that means k kilometers over, let's say t minutes, will be equivalent to 30 kilometers over 1 hour. Cancel the kilometer, solve for t, that's k over 30 hours or 2k minutes, which is consistent with our previous answer. Wait a minute, but didn't I just say that you did not have to know the formula at all? Well, you don't, because even if you flip the ratio and make it T1 over D1 equals to T2 over D2. Sorry, there is a little bit typo. These two should be D2 and T2 respectively. My apologies. So as I was saying, even if you invert the ratios, as long as you have T or D on the numerator consistently, you will get the right answer. You can check it out yourself. Oh yeah, and I almost forgot. Didn't I say there was an instant in which instead of D equals to RT, T equals to DR was the correct formula? Now, in order for this to be correct, your rate has to be time over distance. Can you think of a situation in which rate is expressed as time per distance or hour per kilometer, minute per kilometer? Are we getting closer and closer? Minute per kilometer, minute per mile. Does that ring a bell? If you're thinking marathon runners, you are 100% right. And if someone is curious, as of today, the fastest marathon runner, Eliud Kipchoge, runs less than 3 minutes per kilometer, which I believe is a little under 5 minutes per mile, which is outrageously fast, if you ask me. Okay, back to GMAT and GRE problems. While problems with this inverted unit of rate are less common, I have seen some problems in the official sources that feature such units. Alright, here's an example that I just made up. If you want, you can pause the video and solve the problem and put your answer in the comments. Okay, for Mbru, rate is 3 1/3 minutes or 10/3 minutes per kilometer. Distance is 42 and the formula is T equals to DR. You know, if you're really not sure about the formula, you can always use the proportion. Here, 10/3 minutes for 1 kilometer. How many minutes for 42 kilometers? That's 140. For everywhere, the proportion will be this. Therefore, time equals to 168 minutes. And finally, subtract 168 minus 140 is equal to 28 is the right answer. By the way, there is a really short way to solve this problem using which you can probably answer the question within 30 seconds, as you can see on the screen. Now, this video is already too long. I don't want to keep you here any longer. So I made a separate short video explaining the shortcut. If you want to watch it, the link should be in the description. And by the way, don't forget to watch that video with the units conversion. Link will be in the comments as well. And as always, thank you for watching.